Hello, Twitch and everybody out there. Glad to see you back for another episode of Happy Little APIs. I have with me again this week the ever large beard. He has the better beard. That's all I got out of last week. But over here to my left is Bob Kinney. Bob, tell us a little about yourself.
So for anybody who didn't hear me do the spiel last time, so I'm a senior developer on the API Gateway team. Been with the company for about 7 years, specifically on API Gateway for about 3.5.
Excellent. If you're new to this stream, what we're talking about is API Gateway, or APIs on AWS, and the fact that APIs should be calming. It shouldn't stress you out. So we're trying to tell you all that API Gateway can do and how to build best practices for APIs on AWS. And today we're going to be talking about securing the front door, about what it takes to lock it down. Let me go ahead and bring up our share here. All right, as you can see, this is Building Happy Little APIs. That's my beautiful mug right there. And today's episode is called, excuse me one second here. Today's episode is called Building Happy Little APIs, Shut the Front Door, again with Bob and I. And we're going to jump right into it. Now, Bob, last week we built a very basic, kind of stemming off what George had built the week, or not last week, but last episode, what George had built the episode beforehand, and we built a weather app. And just to kind of remind you all what we're looking at, this is what we built last time. We had a simple client. Really, our simple client was just a web page doing GET calls. And then we were using API Gateway with a Lambda function and a Dynamo database filled with weather data. We wrapped around that last week Amazon CloudWatch and Amazon X-Ray, and we talked through debugging and figuring out bottlenecks and such. So, great week. This week, we're going to talk about what it looks like to secure that weather application. And kind of the idea we're going to be talking about today, and some concepts we're going to talk about, is what does it look like to secure the client who's making the call to API Gateway? What does it look like to secure maybe an external service sitting even in another account or somewhere else who wants to push updates to API Gateway? What about AWS WAF or cores? One of the things that we see a lot of times is developers just banging their head against the wall when it comes to cores. I mean, that can be tough. So we'll talk a little bit about that as well. So let's kind of break this down. And Bob, jump in any time. But as we're looking at security, one of the first things we're going to talk about are authorizers. And with authorizers, there's really kind of three kinds that we're going to look at today, and specifically use two of them. The first one is a cognito authorizer. And this is built to allow Amazon Gateway, API Gateway to link into Cognito to get authorization from Cognito. So a customer or a client can authenticate through Amazon Cognito, and then they can authorize their Amazon API Gateway using the Cognito authorizer. The second thing we're going to look at is this idea of an external account. We're going to kind of mock this up to show you what we're looking at in using an IAM authorizer, which says we can do cross-account authorization via resource policies. So you get this idea of, hey, maybe the resource that we want to talk to our API Gateway is not inside of our AWS cloud. Maybe it's in another account, or maybe it's off somewhere else. So with an IAM authorizer and using resource policies, we can kind of list that out. Bob's going to go in more in depth in that. I get to talk about it. Bob gets to show it. So he's the smart one in the group. The next thing we're going to kind of show here, and we're not going to show an example of this, but to kind of get an idea is what we call a custom authorizer. And this kind of takes the idea of we can have a Lambda within our account that the API Gateway can talk to that can really do kind of any number of things. It's custom logic. And so you can reach out to your data center, or maybe an external web-based service, or even a custom AWS services hosted inside your account. Really, it's kind of up to you. However you do that, you can respond with yes, they're authorized, or no, they're not, based on the custom logic that you have. So all three of these authorizers are things that you can build right into API Gateway, and you can do that.
We're going to show jump in for a second, Eric.
Yeah, jump in.
Yeah, so I kind of wanted to make one sort of delineation here. So the first two that we demonstrated you as a consumer or a customer of API Gateway wouldn't have to write any code. It's mostly just configuration of the authorization and configuration. So for the Cognito Authorizer, setting up the user pool for authentication and then configuring it. In the custom authorizer, you have far more flexibility to sort of customize how you handle the authentication. And as Eric was mentioning, you can integrate it with sort of any number of third-party services to kind of return back the response. And much like a lot of the integrations with Lambda, there is a sort of a well-known protocol where your Lambda will receive an event which will describe the context of the request, and then you reply back with a response which includes any identity information you might want to include as part of the authentication result, as well as a policy that describes the actions inside of that API that the user can actually perform.
Excellent. Yeah, thanks for clarifying that. So what you're saying is there's a specific format that data is going to come to you, and then a specific format that you need to respond in, right?
Yeah, exactly. And that's documented. Yep.
Okay. All right. So the next thing that we're going to kind of discuss a little bit is AWS WAF, which is a Web Application Firewall. And this is great for blacklisting and whitelisting IPs. You can do an IP range. There's some logic you can put in there. And Bob's going to walk through the console on this, kind of show you what this looks like. So this is kind of another good way of protecting the front door of your API gateway. And then the next thing, or the last thing we're going to talk about before we get into demoing is CORS. And again, cross-origin resource sharing. Man, if you're a developer, when you're working with local environments, then you're working with production environments, CORS is tough. Amazon Gateway takes a lot of that and abstracts it away for you and allows you to do it. But there's still some things that you need to do. And so, Bob, you can help us kind of draw the line there, right?
Yeah, so I'd like to describe this as part of our sort of shared responsibility model, where there's certain things that we can do for you, and then there's other things that you as the customer running on top of API Gateway would be responsible for. So the first thing is that if the error result is something that happens inside of API Gateway, all of that will be handled via what we call gateway responses. And so you would add your custom CORS headers to your gateway responses to actually define the sort of the error handling there. Then if you use SAM or the one-click CORS experience from the console, we will also create a pre-flight options request, which will be a mock request. And so that, again, API Gateway will sort of manage all of that logic for you. You just have to configure it. And you're just, again, specifying the headers that you're wanting to whitelist and the methods and origins you want to whitelist. Now, where it gets tricky is if you start using the Lambda Proxy integration or an HTTP proxy integration where you're calling back to the backend. And this is where you can end up in a situation where you will yourself have to return back the CORS headers from your integration. And so we'll have a demonstration of that in our Lambda function a little bit later on. But that's so. When your Lambda function is called and you're using the Lambda proxy, API Gateway doesn't have any ability to override the headers that are returned back. So it is your responsibility as the API owner to make sure that those CORS headers are returned. And the same thing is true of the HTTP proxy. But if you're using the non-proxy methods, so you're using the mapping templates and header definitions, you can actually control that inside of API Gateway if that's an option you want to pursue. Yeah,
and I would point out if you're hearing these terms proxy and integration, you're kind of scratching your head trying to figure it out. I would go back to episode 2 of our Happy Little APIs, where we actually talk about what is the difference between API Gateway's proxy and integration. And specifically for this, when a proxy request is made, all API Gateway does is wrap some contextual data on the request and send it through to the backend. And then the response, it doesn't do anything to the response. So that's why you have to do the CORS headers, because it will do that. Now again, and as Bob said, when it's an integration, then you have a lot more control at the API Gateway level. But if that's confusing, you go back to that episode and that'll explain a lot. So. All right, well, let's, as much as people love to hear us talk, they probably want to see some code too. So going back to our final idea here, looking at this, there's a big difference between what we built last episode, which was an unsecure application. It was just an application that you go out to and it works. Whereas now we want to make sure people are logged in. And in this particular application, and we'll kind of define this later on as well, but we're going to have two options. You can either hit it non-logged in, so we want an open endpoint for our clients to hit where they can just get data back, and you have an authenticated login that our clients can hit and get weather. And then we also have an endpoint that our service is going to hit that Bob's going to walk you through. So we're looking at three different types of endpoints, three different type of authentications. So Bob, you ready?
Yeah, sure. I'm going to go ahead and take over here.
All right, I'll turn it over to you.
Okay, so first we'll just start off in the API Gateway console, and we'll give a kind of a brief overview of here the methods that we actually have configured, and I'll go through the SAM template as well. But we have here at our top our original get method, which was basically the method that we had configured in the previous episode, which was just a Lambda proxy going to our Lambda function, which was fetching the data directly out of DynamoDB and then presenting the JSON response, which you can see here. So this is again our non-authenticated endpoint where I'm just querying for a specific zip code and then returning back a JSON response when I get a valid request. Additionally, we have, so that, again, that one is open, so there's no authentication on it whatsoever. Then we have our premium API, which is going to be configured with the Cognito user pools authentication. So this will require that a Cognito user is logged into our API or our linked user pool in order for them to actually see the data. So I can actually go over here to my browser and try to actually hit the same URL with premium. And what I should see is an unauthorized. So this is API Gateway saying like you've not authenticated, and because I'm just doing it in a bare browser, I don't have any cookie or session associated with a Cognito user, so there's no authentication to be had. So that's that. That's our premium, and then finally we have our admin API, which only has a put method. So this is going to be our think about it as like we have another service that's running somewhere that's actually running our meteorological analysis to actually get our forecasts, and is pumping data into our backend, and we're exposing an API for that system to pump our data into our user application. So it has a nice separation of concerns there. So let's take a look at the front-end API that we built, and hopefully we'll have some time to actually talk about how we actually built this front-end. But we have here a really simple front-end where I'm not logged in right now, and I'm going to get data. I chose this particular zip code. This happens to be my hometown, so hi to anybody who might be from Merrimack, New Hampshire. And so I can see here sort of the current conditions in Merrimack as according to my database. And so this is all just using the public API, but it has a nice front end. It displays a picture. So in the application, we've got JavaScript code that's actually just calling out to the public endpoint. Then I can sign in. And I've already got an authenticated session, so I'll just go ahead and pull that in. Now that I've authenticated, if I go ahead and pull that same data again, or that same zip code again, I get the premium data. So I'm actually getting the forecast, not only just the current conditions, but the premium forecast content that we've decided to lock behind authentication. And so I can then log back out, research again, go back to only getting the unauthenticated data. And as we demonstrated inside of our other browser tab, I can't actually get at this data unless I'm actually authenticated with Cognito. And I'll reserve some, hopefully we'll have some time and Eric can go through the Cognito configuration that we had for that setup and as well as the client. So now what I wanted to touch on is, well, let's jump into the SAM and take a look at what that looks like. Because there's some interesting things here related to making this stuff work with cores and as well as with JavaScript APIs. So we talked about the shared responsibility model and the concept that the Lambda proxy is going to be responsible for actually returning back the appropriate headers as part of the response. And so you'll see here that like at my sort of wrapper function that I have inside of my Lambda function that wraps all of my responses in JSON in the JSON proxy response always includes this access control allow origin, which is sort of the absolute top level CORS header that you might be interested in. Now, I've obviously just done star here. I'm still doing development. We haven't quite gotten to sort of live production. Maybe when I want to lock that down, I can actually put in the correct domain for my actual hosted application. But at least for right now, I can just put in star and kind of work through my development environment. So that's the core side on the Lambda. But then if I switch over to my SAM template, SAM has a couple of nice things that make this a little bit easier for some classes of problems. Where I define my serverless API, I can actually have this great little property called CORS. And I can actually define the allow headers as well as the allow origin for the pre-flight requests. So SAM will actually generate those pre-flight options requests for me when we push the updates. So if I switch back quickly to the console, you can see these option requests that are actually the things that are being generated. And if I go to the integration response and fold down and go to the header mappings, you can see these headers that are getting generated for me on the fly. So I have my access allow control headers, which I defined in my SAM template, my access allow control origin, which was also defined in my template. And then SAM is actually doing the methods, so the allowed methods, it's actually determining that based on the methods that are actually defined in my SAM template. So if I had
if that's all right.
Sure, absolutely.
So we had a question. I'd like to get your take on this. The question was, does anybody not use the quotes, star quotes? Sorry, I always forget the quote names. The quote star quotes. What do you think? Should people use quote, the star, or should we hard code or pass in specific domain names? What's your thought on that?
So I mean, it kind of depends on whether or not you're building a multi-tenant application. So unfortunately, the core spec is not really great about sort of allowing multiple domains. So it's really kind of one domain or star. So if you're hosting a multi-domain application, then star is kind of like the only option because there's not really great methods for sort of programmatically generating that, at least today in API Gateway. That's sort of my answer. So if you're generating something that's being used in a multi-domain, multi-domain hosted environment, multi-tenant, then star is probably, unfortunately, what you're probably going to end up using. But if you're building purpose-built APIs with only one tenant, one domain, then absolutely it makes sense to actually hard code that domain because that's sort of the whole point of CORS in the first place.
Okay, cool. Thank you.
Okay, so we're talking about the sort of the stuff that SAM kind of gives you sort of out of the box, so again, this gets defined at the API level, and so all of my methods or my events that are tied to my serverless function inside of SAM basically inherit all of this configuration. So when I'm actually defining my methods, I actually can I don't even have to worry about it. It's set at the API level. All of the methods underneath that inherit all of that configuration. And so you see here, I have my get weather, which is my non-premium, which is at the root and a get method. I have my admin API, which only supports a put and uses the AWS IAM auth. And then I have my premium path, which is a get as well, but then it uses the premium user authorizer, which is configured down here with our user pool that is also created, again, inside of the SAM template.
Okay, so I'm going to interrupt you there again. Can you go back into the function? So an interesting thing to note here, you're using the same code base for all three of these endpoints, right?
That is correct.
Okay, so you have an HLA is the folder that your endpoints are. And can you go down to the events there? So something to notice, a lot of times what I see is people will set up, different actual function inputs in their template, whereas you can have multiple events calling the same code base, just changing the path, changing how you want them to trigger.
Sure.
So good SAM structure here. It's something I wanted to call out.
Yeah, so I mean, it kind of there's obviously going to be a tipping point where like there might be too much code in your Lambda function, and you might want to have some separation of concerns. At least for what I was trying to do here, it was sort of lightweight and simple. Particularly the premium and the non-premium, the code is basically almost the same. I can literally kind of go over here. So the only real difference between the premium and not premium is the fields that we're returning back from Dynamo. So that. It didn't seem like that was a good place to kind of have a separation of concerns, but certainly like the admin API, I could see an argument for having like a dedicated Lambda function for if you wanted to do that. I chose not to do that here just so that I could reuse a little bit of code inside of the same Lambda function.
That makes sense. Thanks.
Yeah, no worries. So again, some more configuration here for the Cognito user pool. So this is again, I've kind of punted a little bit here and sort of done an auto confirm. So I'm not doing any workflow for confirmation of user where I try to have them click a link and validate their user. It's literally just if they sign up, they get an account and immediately they can start using it. And that's pretty much it on the SAM side. We can take a quick look on the rest of the Lambda function. Again, I'm reusing the same function here or an extension of the same function that I used in the previous episode. So I still have all of my X-ray logging enabled for my function, and so I'll be getting traces on that, assuming I set my sampling rate high enough. Again, my gets are basically the same, except it's whether or not it's premium or not, and that's going to be based on information from the request. And then my put method is just going to take whatever gets put in and then pipe that directly into my table using Bodo. I'm not doing any sanitization here. Obviously, there would be some additional work might need to be done in order to sort of get this ready for sort of a production rollout. But at least for our intents and purposes, gives us a good idea of what we might be looking at. So now what I'd like to do is talk about how we actually set up that admin API, so that separation of concerns, where we have a separate account that's generating data and then pushing it into our API gateway. So when you enable AWS IAM, by default, only credentials in the account that actually own the API can actually can sign requests and send to that API. So if I have another account and I try to execute the assigned request with credentials from another account, I get this very helpful error. Hopefully, people can read it on the stream. Let's see if I can zoom in a little bit here.
There you go. Yeah, that's better.
So you can see here a helpful error message that's saying that the user that I'm using, which is from a different account that owns my API, doesn't have permission to access this resource. And again, this is by default. Unless you're using credentials inside of the account, they're not going to be able to execute a signed AWS request. But recently, we launched what we call resource policies for API Gateway. And so I can actually go over to my API, I can click on this resource policy tab, and then I can attach a policy to my API and then deploy it. So this is an operation that does require a deployment. So if you modify the policy here, it does need to be deployed before it will become effective on the actual API. And the language that you use here is basically the IAM Policy Language. And you basically will define rules that you can set based on either a signed-in user or a particular path or parameters in the request. Basically, anything that you could do from an IAM policy standpoint, you can define rules for the resource policy. So the important thing to note about the resource policy is that it will be applied in intersection with the existing policy on the credentials. So if your credentials on your account don't allow a specific action on the API, but the resource policy does, or if there's an explicit deny, excuse me. So if there's an explicit deny in one of the two, then that will always override. So there's a long list of policy sort of best practices in terms of like whether or not it's an explicit deny, an implicit deny, or an explicit allow. And so if you ever have an explicit allow, then everything is fine. If you don't have an explicit allow, then it's an implicit deny. And then you kind of like have these fights out where if there's an explicit deny and an explicit allow, it can create conflict. Anyway.
Hey, Bob, can you blow that up too so we can show the policy a little better? Thank you.
Yeah, absolutely. So right here now, I'm literally just allowing this user, which is the same user that we saw in our error message over here. So this is the user whether admin in this account to basically execute anything in this API. Now, strictly speaking, this is a wildcard across all APIs, but because the policy is associated with this API, it does not extend beyond this API. So what I should be able to do now is I should be able to save this policy and then not forgetting to go back and actually deploy it so that it will actually be applied on my stage. And then I'll go over here and I'll look at my, this is my response. Where's my, okay. Seem to have lost my content. Okay, so now what I want to do here is actually like send a message to my function, which is going to update all of the fields. So I will go back to my non-premium data and grab that. And so now what I'm going to do is construct a message that will send to my, where's my, apologies, I'm having a tool problem here. There it is. Okay, it's already there. My apologies. Okay, so now I have my a message here which I'm going to send to the server to try to update all of the fields. Now, again, I'm not doing any sort of like partial updates or anything. So whatever I send is literally going to get written out. So I could potentially update the location name, today's conditions, tomorrow's conditions. I'm only going to touch the tomorrow's conditions. And I will say that like tomorrow is going to be 88 and clear. And so I'll go ahead and send that request. And you can see here that I got a very helpful success message from my API. It shows me the item that was put into the database. And then I can switch back over to my authenticated client, make sure that I log back in so that I can see that premium content. To refresh, try that again. Seem to be having a...
Did our client die? Interesting. Try another zip. Try 85034. Oh, there you go.
Well, that's interesting. Live demos. Okay, so let's see if we can take a look here real quick and see if we can figure out why we might be doing this. Actually, why don't I do a little bit of debugging here? And Eric, why don't you talk a little bit about the front end application, and
sure.
I'll see if I can dive deep here and figure out what's going on.
Alrighty. So I'm going to jump over here. Both Bob and I can fat finger sometimes, and so it's always fun to try to figure out what we've done wrong there, why he attacks that. So I wanted to show on the front end, and I don't want to brag, but yeah, I designed the front end. It's pretty amazing. But I wanted to show real quick, if you're not familiar with Amplify console, so I built the front end in Vue. And with Amplify console, I can point it. Right now. It's in a code commit repo sitting inside of my account. I can point the Amplify console at that code commit, tell it that it's Vue. I can set some build settings here that you see, and actually, because it recognized that it was Vue, it knew to set that up. And then I can go through and that's how I built the front end. And so then every time I commit to code commit, it builds out the client side client side client. So here, and I'm going to see here real quick here. Yep, he's still working on that though. But so that's a link to that, so you can build that out. You can break out, you connect different branches, so you can build your staging. So this is a great way, basically, if you're a developer and you deal with client side, this is a great way to do quick client side CI/CD. And so I built that out. Now the second thing I want to talk through while he looks at that is, when we set up the authorizers, there's a couple things that we need to do. SAM, like he showed you, the SAM template will set up all the cores. It actually created the user pool that we need. It created the app client that we need for the user pool. But what it doesn't do is set up that fancy login that you saw. So if I want to go log in, I click this, and you'll notice up here in the domain, and let me blow, I don't think it'll blow up the right areas, but you can see that I'm hitting weather and then it's an auth site incognito. So these are my authentication domains that I'm using. I actually created the weather, and I'll show you that in just a minute. I also am passing in I'm grabbing the redirect back, and here it's passing back to my master domain, and I'm passing in my client ID. So I log in, I use a password, and then and actually I'll go ahead and do that so you can see this. All right, so I sign in here, and it takes me back here. So now I'm logged in. Nope, don't want to do that. And we're good to go. Now, the interesting thing is, SAM won't set all that up yet because not all of it is supported in CloudFormation quite yet. So what I did to enable this is I'm going to come in and first thing I'm going to do is come to my app client settings, and I'm going to turn on my identity provider. And my identity provider is my Cognito user pool. That's the only thing that I've got linked in through this. The second thing I'm going to do is I'm going to tell it my sign in and sign out URLs. Now notice, I don't know if you can see it here. Let me see if I can blow this up. You'll notice that I've got two URLs. This is my test domain. I was using Cloud9 to build this out. So that was my Cloud9 test domain. And this is my production domain. So my sign out URLs are the same. I log out, it'll take me back there as well. The next thing I'm going to do is I'm going to tell it that I want to use authorized code grant, which is the way I'm doing this. And how that works is when my client goes over here, when it pops over here to do the login that we saw, it's going to get a code back from Cognito. And I'm going to take, my client then takes that code and it hits a token API, and it exchanges that out for an access ID. And then that access ID is what's passed through. And then we could do, if we aren't using scopes in this particular example because that takes longer than the time we've got here. But if we wanted to scope some things, we could do allowed OAuth scopes. Now I've got them turned on for later purposes, but we can turn those on and off. So with those set, then I save it. Then I go to my domain, and with my domain, then I can choose. I can try different domains. I chose whether it happened to be available. And then that's it. And so then once you put that in, that's the address that you're gonna hit. And so let me walk you through this again. So let me log out here real quick here, log back in. You see the address again. So we're gonna pass the client ID and we pass a redirect URL and we hit the domain that we suggest and And that's a quick way to build an authentication service. And again, this goes back to that, when we looked at our diagram, shows you authenticate here, and then you authorize at the Cognito user pool. Bob, how you doing?
So I'm getting real close. I'm pretty sure I know what the problem is, but I need another minute or two.
All right, so then what I'm going to do is I'm going to go to the back end, and we're going to go back to the template that Bob was showing and make sure everybody can see this okay. All right. So that's what I want to do here. So one of the things, when you go into the authorizer here, when you're setting this up, now Bob walked through the template there, and we go back down to our API that I was just at. Just one here. Okay, so in the API, when I pass my authorizer, this is just the logical name of my authorizer. The next thing I do is I'm going to get the premium pool, user pool on. And so that user pool was created with Sam here. Okay, and then the user pool client was created here and ties it together. Once I have that ARN put in place, then that locks in. Then what happens? That's where it ties your backend application, your API gateway, to this Cognito infrastructure that you've built up. So it knows, because it knows that the ARN of that user pool, it knows to use that when we're authenticating, when we're passing our token around. So that's pretty much the meat and potatoes of a Cognito authorizer. And you can do obviously other types of authorizers here, but this is how we're building this out. So on this, so here I'm calling. You notice that he said I'm directly calling an AWS IAM authorizer, so I don't have to build an AWS IAM. That's already built in, and then I'm directly calling this authorizer that we built. And so launching that, we'll build that out. And what I've done is I've taken and I've built a Cognito for different applications that I'm doing. I basically take this here all the way down, and I have just a reusable template. I know some of you and I have been on a conversation on Twitter over the last week or so about building reusable blocks in CloudFormation. This is one of those that'd be good to have in your library. If you build a Cognito infrastructure that you can pass in an application name and change out that, and use that name in the subs, then you've got this, and you can reuse it for different apps that you're building out. All right, so those are the two things that I'm going to walk through here. And the last thing here, I'm going to go into a little more in depth on what Bob was talking about, the inline code here. One of the things that you may not recognize is that you can pass inline code when you're building a function. Now this, I don't know if this is always the one that I would suggest for all your applications, but it's something that I use periodically based on the application I'm building. I've had clients say, "Look, we don't want to do a confirmation of our email or our phone number. We simply want them to be, if they're signing up, we want it to go through, and we go." And I actually don't suggest that too often, but for our demonstration purposes, that works. So simply, all this is doing is an inline. When you're building for Cognito, you can do a sign up Lambda function, and it fires this function. You notice it's called the pre-sign up, and there's several lambdas you can fire: pre-sign up, post-sign up, I think pre-login, and they fire this, and you can grab the event. You can update the event. So in this example, we're doing event response auto confirm user. And then finally, you can change that. You can look at the email and everything, make sure it's good. And then you actually say auto verify phone, or whatever you're going to do, email and phone, to true. This allows you to get by that verification process. Someone can log in, they're able to use it right away. All righty. We're going to jump back here. Bob, you let me know when you're good there.
Yeah, unfortunately, there seems to be a interaction with the Cognito and the Cognito user pool and the resource policy that I'm having a little problem with, and I'm going to have to go back to my team with to make sure that we're doing the right thing. But I can at least go back to demonstrating sort of the update actually taking effect and taking a look at that.
Excellent. Okay, I'll let you jump on it.
I'll go. and then we can talk about the rest of the stuff we wanted to talk about.
Yep.
So now I can see that I can see that the data has been updated with the 88 degree temperature for tomorrow for this location, and I can see that. Unfortunately, I had to remove the resource policy in order for that to work. So the TLDR there is that there's a policy configuration which I thought I had in place, which was not working, but unfortunately I'll have to defer that to perhaps a later time. So the last thing that we want to kind of to touch on was WAF, and so certainly when you have a public API that doesn't have any authentication on it, there's not a lot of mechanisms for sort of shutting the front door, so to speak, as we were talking about, as the title of the talk suggests. But one way that you do have to shut the front door is what we call WAF, or the Web Access Firewall. And so WAF allows you to define rules for evaluation, whether it's as simple as blocking an IP address or blocking certain classes of traffic, so rate limiting customers based on IP addresses. Now, unlike a lot of the other features integrated with API Gateway, you actually define everything in WAF from the WAF console. So I've switched over to the WAF console, and I'm going to go ahead and configure a web ACL here. I have to give my web ACL a name. And then I define the region. So this is how I scope down to figuring out what resource I want to do. We're running in the Oregon region, which then allows me to select API Gateway as a resource type. Or then I can select my REST API, and then I have to associate a specific stage. And so then at this point, then I am able to then configure any number of rules for this ACL to actually control. So whether that be checking for cross-site scripting configuration, or IP mismatches, or SQL injection. So WAF has built a whole bunch of custom rules that will allow you to kind of detect these kind of problems and reject the traffic before it even hits the back end. So the clients will get a 403, and you don't get charged for any of the requests that get rejected due to WAF blocking the request. So so if I just want to create a simple condition for an IP block, and then I can define either, so IPv4 is currently the only thing that's going to be supported for API Gateway, and then I can either do a net mask or an explicit IP. So if I literally just want to block a specific IP, then I can add that range here. Of course, it would help if I actually picked a correct one, so let's just do this one. Okay. Has to be. So if I want to do a specific IP format, I actually have to do it as a CIDR /32, and then I can create that, and then all of the traffic coming from that particular IP address would be blocked going to my API gateway. Then I just need to review all of those things, and then I want to block any requests, allow that don't match. So that's fall through. And review and create and confirm. And now at this point, behind the scenes, WAF is communicating with API Gateway and communicating and saying, now my API should behave on this rule. Obviously, I'm not actually testing from that 8.8.8 IP address, so I'm not going to be able to necessarily demonstrate that. But that's how you would actually set up an ACL for your API.
So a couple of questions for you, Bob. So let's say I match the rule. What happens to the request? Does the caller get a response, or is it just dropped?
Yeah, so it gets a 403 response as if it was unauthorized. So it basically just tells the caller to go away. And again, that 403 is not charged to for API Gateway. So now obviously there is a charge associated with using WAF, but there would be no charge associated with the API Gateway request that was blocked due to a WAF rule evaluating to block.
Okay, so what's your take on when would I use a WAF? When would I use a policy statement, a resource policy, or something else? Is there guides on that?
We have seen, so before we had active integration with WAF, we were seeing a lot of customers doing basically primitive WAF with resource policies and IP conditions in the resource policy. That doesn't scale particularly well. If you have a very small number of IP addresses that you're trying to block, that is one, that is something that you can do, but it does not particularly scale. Basically my rubric is that if you're authenticating, so if you're authenticating the request, then you should be able to do something inside of the policy definitions to actually control that. If you don't have any authentication, then WAF is a great choice. So if you have a public API that has an endpoint that is otherwise unrestricted, then using WAF is a great mechanism for protecting other callers of that API from a bad actor.
Okay, I appreciate you saying rubric instead of rule of thumb. I don't like rules of thumb. You know that, right? I'm just messing with you. We do have a question here, and we might take this offline, but I'm going to throw it at you anyway, see what you think. This is a little off topic, but going with security, says, I have an application that users can subscribe to services. They should only be able to access files stored in S3 that come with these services. Right now, when they have the URL, they can access everything a registered user can access, but is there a simple way where I can restrict that? So what we're looking at doing is restricting data to an S3 via an API. So does that make sense?
Yeah. So I guess it depends on where the credential's being asserted. So if you're giving the customers like a pre-signed URL to access the S3 resources, then obviously your application that's generating the pre-signed URLs can assert whatever rubric it wants, whether it wants to store information in a database that then says that this user should have access to this content, then fine, you can definitely do that. If you're relying on S3 permissions to do that, then oftentimes what customers will do, and what I've done in sort of personal projects, is using prefixes. So if you have you can define access to an S3 bucket based on prefix path. And so you could say that there's certain classes of users or subsection or sub-services that have files in there. And you just define all of the subpaths that the user would have access to in a policy. And then you can have your users directly access S3 without necessarily having to use API gateway in between.
Okay. Well, and that would be, either way you do it, and just to go back, when you do like a pre-signed URL, something like that, you never want to route your calling of an S3 object through your Lambda, through your API. You always want to have it directly talk with S3 when you can.
Particularly if you're talking about larger payloads or larger sizes. So API Gateway has a 10 megabyte payload restriction. Lambda has a 6 megabyte payload restriction. So if you're talking about files in that order of magnitude, then definitely having your customers access S3 directly via pre-signed URL is definitely something that I would recommend.
That's right. Okay. All righty. Okay. What else? Do you have anything else you want to show on the WAF stuff?
No, I think that was all I wanted to show on the WAF stuff. So I think we're sort of at the end of what we wanted to show today.
Yeah. So and please, if you have any questions, we have a few more minutes before we have to jump off here. Love to answer any questions. We can answer them online if we know them. I'll answer that. I'm going to go off topic here, but we had a question about since we did talk about Amplify console. Actually, let me ask this question real quick. Okay, could I serve? All right, Bob, let's throw this at you. Stop the chump. You ready? Could I serve JS files through AWS Gateway, which is located behind Nginx? Yeah?
I'm not sure I completely understand the question.
If I'm understanding it correctly, I've got an Nginx proxy server. Could I put API Gateway in front of Nginx proxy server? And that's, I'll jump on that, Bob, correct me if I'm wrong, but yeah, absolutely you can. The beauty of API Gateway is you can point it at anything that has an endpoint. So if your Nginx if your proxy has an endpoint and you're serving up something through that, you could do it. You might find that and this is brought up earlier in the chat, you might find that with an integration, you might be able to get rid of the Nginx proxy for whatever reason you're using it. And so I did get a request. Katie pointed out a Raspberry Pi. If that Raspberry Pi has an input that's public to API Gate or public to the internet,
as long as it's public routable endpoint, we can call into it.
That's exactly correct. Yes, this video is recorded. The question was asking, are these videos recorded? All our episodes are recorded and can be found on Twitch and YouTube. So I encourage you to go back and follow them. I will answer the my opinion on the Amplify and the Amplify console question. The question we got was, you can do Amplify push, and then you can also use the Amplify console. And they're really, you're almost taught. Amplify is an incredible product, and I love it. I work in the serverless group, and it's tied in heavily with us, and we use it quite a bit. And you can use, Amplify, you can use SAM, they integrate, there's a lot of overlap in them. And kind of the advice that I give, and again, this is the Eric Johnson answer here, is if you're coming at it from a front-end developer, Amplify and the Amplify tool set, like the CLI, a great way to go. If you're coming at it from like a back-end developer where you're kind of building your APIs and things like that, then SAM is the way to go. And then you'll find some overlap as well. And Amplify depends on SAM, and there's some integration. The Amplify console, however, is its own kind of service that allows you to host and kind of a quick CI/CD for front-end applications. So hopefully that helps. That's my opinion. Well, I think we're about out of time. I would Bob, thank you so much here. I really appreciate it. Let me bring my slide back up here to let you guys know what's going on. So this is what we built today, our secure weather application. And we had, and Bob, we're going to be checking on what kind of messed up our last part. Maybe we'll publish that out on Twitter later. But if you next week, so we talked about shutting the front door, but that's not always enough. Sometimes you want to shut the back door. And so next episode, we're going to be talking about what does that look like? How do you validate the API gateway? Is this the right API gateway that's hitting your application through using client certificates? We'll discuss the idea of trust but verify. So you know someone's authenticated, but let's make sure they're who we want them to be. And then we can also protect our backend through technologies like VPC links. And we'll visit throttling again. Throttling is great to protect the backend from, when we talked about earlier, from getting too many requests, but it's also good from getting hammered from like a denial of service or something like that. So look forward to seeing you on June 11th, same time, same place. Appreciate all the folks who follow and give us questions, and we will see you next time. Bob, thanks again.
Yeah, absolutely. See you next time.